Good afternoon. Thank you to Breakbulk for having me. I would like to start and invite you to visualize an image in your head. It's 3 o'clock in the night, and we are in a small village in the middle of Europe, and there is a convoy trying to transport through that village a wind blade, which is longer than a football field, and then the crew is starting to disassemble the traffic light and all the obstacles, and slowly they bring the wind blade through this small village in the middle of the night. Something like this is invisible in general to the general public because it happens very often in the night. But it's like what energy transition looks like. And about the energy transition and the contribution of heavy transport in the energy transition, we are going to talk in the next 20 minutes. My name is Filippo Baldassari. I'm the Managing Director of the TII Group since 6 years, and at TII we will see some pictures afterwards. We deliver a lot of special equipment to our customer, transport companies, and most of the projects they are in today is related to the energy transition, so we are particularly passionate about it. Heavy transport, like this image at 3 o'clock in the night in a small village shows, is the silent backbone of energy transition. Silent because it's not really transparent to the public, but nonetheless backbone because it accelerates enormously the transition to a decarbonized world. Obviously, heavy transport has a dual role. Heavy transport is not only an acceleration, an accelerator to energy transition, but it's also a CO2 emitter itself. And through a little bit this dual role, we will reflect what are the consequences and what are the solutions through the presentation. Key success factors, we will reflect them as well, are, in my opinion, technology and innovation, and a clear, stable and realistic policy making without which energy transition is not possible. But first thing first, let's have a look at the chart on the left. That is the CO2 emission by the world from 1940 to last year. Last year, the world has created an emission of 38 billion tons of CO2. And if you look at what was the emission in 1940, it was 5 billion. So we are talking about 38 billion against 5 billion few decades ago. And what is extremely interesting, in my opinion, is if you look at these 2 years, 2009 and 2011, the CO2 emission went minimally below the year before. Why? Because 2021 was COVID, and 2009 was the financial crisis, the famous Lehman Brothers story. So in 2021, even if the world stood still, we didn't transport anything, we didn't take a flight, we were in many countries not even allowed to use our car, the world has basically had the same emission as normally, which shows that the decarbonization of the world is the challenge of our generation, because we have to move from the carbon-intensive systems which we have today to new, cleaner and greener system, and we have to replace this system because just to reduce the CO2 is simply not possible with the systems of today, like it is shown in the chart. So it's definitely the challenge of our generation. I don't think it will happen in the next 2-3 years. By 2030, we have for sure not decarbonized the world. It will last a few decades, but under certain conditions, which we will reflect, we can succeed in this challenge. The challenge has unluckily become more complicated and more complex in the last 2-3 years because there is a second point coming into the equation, and this is not only decarbonization or energy transition in itself, but it's also energy independence. Energy independence in the world of today and the geopolitical situation of today is very important, because every nation or region has to be able independently to generate its energy without being linked to importing fuel or importing technology from abroad. So energy independence and energy transition, they add up together and they reinforce themselves in some aspects, but they also diverge in some other aspects, and they make the challenge of our generation a little bit more complicated. Where do they reinforce each other? They reinforce each other because renewable are by nature local. So whether we talk about sun, whether we talk about hydro, whether we talk about wind, they are local, and they do not function under the assumptions that we import fuel from abroad. And they reinforce themselves because a distributed grid is a grid with more resilience, because there is not one point of weakness or one point of failure. On the other hand, energy independence diverge from energy transition from our point of view, because the risk of switching from one dependency to the other, moving from dependency in fuel, importing fuel from abroad, to importing technology from abroad. And it opens also other problems. A distributed grid is in general more resilient, but it's also based on a lot of software and a lot of sensors. So cybersecurity in a distributed grid becomes definitely a problem, or becomes a challenge which has to be addressed. The common denominator of energy transition and energy independence is at the end energy efficiency. If we don't achieve in Europe and in the rest of the world a certain energy efficiency, we will not succeed in the challenge of our generation. And here you see on the left, it's a chart from an European community where they estimate the energy efficiency of several European countries. Some countries are already on a good level, especially Northern Europe, but a lot of countries, they are enormous. They have enormous need for improvement. So Europe has to shift and will shift from fuel dependency to technology independency. And technology independency means we need battery factories, we need solar manufacturing, we need hydrogen partnership, and we need technology and innovation in heavy transport, because without heavy transport, and here we come back to my main message, that heavy transport is the silent backbone of energy transition. Without innovation in heavy transport, we will also not make it. So the first question that we usually hear when we hear a debate or we read something in the press is the project financeable? Obviously, money, capital availability is always asked. In reality, if we reflect what happens to this project, capital is in the rule not really the KO criteria. Capital is very often available, but obviously that does not make the project financeable. The project is financeable if there are long-term agreements. If we go win today, not next year, and then win again in 3 years, nobody will invest in the technology. We need stable political and regulatory frameworks. One framework and not 27, if we talk about the European community. We need permitting, we need technology, we need a lot of things, and we need transportation. Because if it is impossible or uneconomical to transport the goods, it will not work. It may well be that money is available, but if there is not the political framework, and if there is not the technical feasibility from an heavy transport point of view, it will not work. So at the end, the most important question even is not, is the project financeable, is there money? The most important question is it transportable? Can it be done? And there are a lot of components which require not any kind of transportation, but they require special transportation. If we talk about offshore wind blades, which are literally longer than a football field, if we talk about monopile and towers for the wind tower, large transporter, you name it, you need heavy transportation. And here comes a point, heavy transport equipment can be electrified if we talk about decarbonization in some cases, but in other cases it cannot be electrified yet. Because the battery would be too big, because the battery would be too heavy, because the battery would take too much weight away from what has to be transported. And because the technology, in some cases, is simply not there. The technology, the electric technology for cars is there, but we don't need the electric technology for cars. We need the electric technology for industrial machines, for industrial vehicles. So, and here we come a little bit to the paradox of heavy transport. Heavy transport is a huge accelerator of the energy transition and energy independence, but heavy transport cannot completely decarbonize itself today, because there are vehicles which can be electrified, but there are some vehicles where we have to wait for the technology to be available. And so heavy transport has a kind of dual role. On one end, it's an emitter of CO2 in itself. On the other end, is an accelerator of energy transition. And in my opinion, here the solution is simply to be extremely pragmatic and recognize that energy transition will take place in the next decades, not in the next weeks, not in the next months, and it will take place in phases. So prioritize sequences is the solution, and in my opinion must be the solution. And we must be pragmatic to recognize that there will be a phase one where we utilize the heavy transport technology of today to build the new cleaner system of the future, which means, yes, once in a while we will see a diesel truck pulling a special vehicle with a wind blade. Yes, it will still happen. Yes, there will still be an LNG ship transporting components for a nuclear plant or for a windmill. Yes, there will be a diesel crane installing a wind tower. But that is acceptable because the CO2 produced in this transport is minimal compared to the CO2 that we reduce in the 20 or more years where the new cleaner system will be in operation. And then, when the technology is mature enough, there will be a phase two where, for sure, heavy transportation has to decarbonize itself even more than today, and where it's possible to do battery electric, we will do battery electric. Where hydrogen is better, we will do hydrogen, but that will be phase number two. I said at the very beginning that at TAI we deliver special transportation system for our customer, and in most of the cases there are energy transition projects behind. So we have at TAI Charles a variety of products. TAI Charles is known especially for the SPMTs, the self-propelled modular transporter, which were invented by TAI Charles 40 years ago. And we will see some pictures where they play an important role in energy transition. And then we have also the brand TAI Camag in the steel industry, in the yard logistic, also heavily involved in decarbonization projects. So if we talk about wind, for example, and wind offshore, SPMT is a key success factor, is a key equipment in order to transport this foundation, to transport the towers, to transport the blades in the harbors. Today, the SPMT, to be clear, what are working in the world are maybe 90-95% diesel, but it is a technology which can be started to be electrified. 1 year ago, we have introduced an electric power unit for the SPMT. Now we start to have some condition and some application where it is thinkable to bring little by little the electric technology. In onshore, we don't have self-propelled. We have trucks pulling special trailers for wind blades, for tower sections. We have also special equipment, special pull trailers for the transformers, for the cable reels, and again, SPMT for any kind of big components, whether it's a carbon capturing plant, a nuclear plant, a hydrogen plant, you name it. If we talk about the steel industry, we talk about a different decarbonization situation, which is, in my opinion, extremely interesting. When you produce 1 ton of steel with a blast furnace, which is the old school chemical reaction, you produce 2 tons of CO2. So I repeat it, 1 ton of steel produces 2 tons of CO2, which is ecologically very challenging. The good news is the steel industry has a solution for that, and it's the utilization of the electric arc furnace, because with the electric arc furnace, you produce 300 kilo of CO2 for 1 ton of steel. So you reduce the CO2 impact by more than 70%. Now, this has 2 consequences. You need more scrap, because there is much more recycling of metal, and therefore you need much bigger scrap transporter than in the past, which we have developed with TI Kamag. And you produce much more slag, which is the co-product of steel, and you need much bigger slag pod carrier, which also we have developed at TI Kamag. Here it's an example of this fascinating machine. And the example of the steel industry is, for me, very interesting because it's extremely pragmatic. These 2 machines exist only in a diesel version today, because simply the battery technology and the electric drive technology for such a big machine does not exist. Still, these 2 machines are massively accelerating the decarbonization of the steel industry, and they will continue to do so in the next decades until, obviously, the new technology and the new green system will allow also these 2 machines to work with an electric drive, whether it's battery system or hydrogen system or whatever. A third example is if you go to a post logistics center or a DHL logistics center, you will typically see the swap body mover on the yard tractor. Here also it's in our range from TI Kamag, the products, and they have been electrified already 4 or 5 years ago. So here it's again a third example where when the technology exists, very welcome, we electrify it. Now, the good news from this year is total cost of ownership have started to be really comparable between electric and diesel, and the electrification of intralogistic will definitely get some speed in the next years to come. So, what are my conclusion, if you will? Again, heavy transport is the silent backbone of energy transition and energy independence, which are the challenge of our generation. Backbone, because without them it's impossible to realize energy transition, but silent because the public opinion does not really perceive it as a key success factor. It perceives it more as a necessary evil, which is a little bit a pity because it's not a necessary evil. The challenge of our generation will last decades. So it will be less romantic that it's written in the press. It will be still based on a lot of oil and steel. And we have to pragmatically accept 2 phases. The phase number 1, where we accelerate the decarbonization with the equipment we have today. And then a phase number 2, when the greener system will be in place, then heavy transport will also fully decarbonize itself. And therefore, we need not only capital for the challenge of our generation, but we need technology, innovation, especially in heavy transport. And we need, obviously, realistic policy making, because if everybody makes unrealistic policy making or fragmented policy making, I make an example. If you want to homologate and register for the road a trailer in Europe, you have 27 different rules. With these kind of frameworks, we will not achieve the challenge of our generation, but we have a couple of decades to improve ourselves. Thank you very much for your attention. Questions or comments?
Now there is a lot of struggling in the world with the political situation, but if decarbonization project for energy goes further, do you see a potential shortage of SPMTs in the world?
I think so, because I mean everything which is more than a couple of thousands of tons to be transported at the end will need SPMT, and we have also seen in the last 5 to 8 years that the world has needed and has used much more SPMT than in the past. So also the number of companies that are available in the world with SPMT for small, medium, and bigger projects has increased dramatically in the last decades. So yes, I think the SPMT will play a crucial role. Because there is no alternative, is absolutely the best solution. For example, in wind offshore, where you have to maneuver with millimeter precision thousands of tons. Definitely, I think from this point of view, we are as CI group in the right application. Thank you.